All right. Hello, my name is Jamie, and today we're going to be talking about CadQuery and dollhouses. So I did a thing. I started this project up in September, and I finished it in October, effectively. This is a fairly large project, and well, large for me. Let's go that route, especially for an initial project in CadQuery. So you see here we've got a fairly complex model. There's it's a dollhouse. It's for my kiddos. Let's show the back piece. It's basically got a front half and a back half. I modeled both. What I ended up printing was just one half of the house thus far. All right. So you see here we've got some interior details. I don't think this shows the flooring at all. Nope. So we've got some interior details. We've got a ladder and we have some stairs. Got some exterior details, arches, get there, casement windows, lattice windows, the kind of Tudor style framing. Ooh, this one doesn't have the roof modeled. Okay. There's roof tiles up here, and then we've got pseudo random stone patterns on the outside exterior walls here. And so this project, this video, we're around basically kind of go through the rundown of how this was built, how it was organized, and kind of talk about this project. So to go along with this, here's the actual dollhouse printed. And let's open this in a new tab. So you can see this. It's 9 sections, effectively. 3 roof sections, 3 sections for the top floor, and 3 sections for the bottom floor. The pieces I printed out primarily is the kitchen front and back, and then the back piece that has the stairs and the ladder. We'll see that in the next picture. Here we go. And so here's the ladder, here's the stairs, and we'll show a better description of that. Here's the floor tiling, inner details. I'll talk about that some more. I did print the piece with a dormer. There's another roof section I printed also with a dormer. And then for the time being, I haven't permanently connected these pieces. So I made a clip piece to kind of temporarily connect them, and it basically allows the dollhouse to be modular. So the kids can reorganize this, make it up into many smaller houses, or pretty much, however they want to play with it effectively. Yeah. And so that's what it thereabout looks at. Like initially when I started this project, I started with a sketch. Yeah, first large project I've attempted to use in CadQuery. Goal was to make a modular dollhouse for my kids. This was the kind of the initial concept. Basically, I was just going to model the front half of the house. Eventually, ended up modeling the front and the back, but primarily just printed the front. It's a Tudor style house with inspiration drawn from basically Google image searches. The central idea is that it would be printed in roughly 9 sections with the floors and roof divided into 3 sections each. Would have 3 sections. And that was the pieces are made large enough so it would fit on the print bed of the printer. Each these main corners, they're 175 millimeters cubes, basically 7 by 7 inches, effectively, and that's about the limits of my print bed. So they're large pieces. Code overview. So this thing is using CadQuery. Primarily, I use CQ Editor as the rendering component so I could see the model. I used CadQuery helper, which is a library that I wrote. Come over here. Primarily for uh, the grid component, the series and the grid component. So if I go to out, what I'm talking about, yeah, a grid. So take a tile of some sort and primarily be able to lay it out into columns and rows grid. So you apply a column, and so stuff like floor tiles or any number of things. And then the other component that I used a lot of was the series. And I don't know if I have a series example in this. I should, but I may not at the moment. But a series is, there we go. A series is basically presenting a tile and then repeating it along a particular axis, whether it's the X, the Y, or the Z axis. Next library I used was CadQuery. This was the main bulk of the library, the main bulk of the reusable code, right? So stuff like let me go to here, image, stuff like Windows. So of course this guy is going to show up confuzzled. So stuff like Windows, there should be a lattice window example here too. Yeah, the stone pattern. It's loading. All this stuff came from this CQ terrain library that I wrote. To install it, I've got instructions in the README for this thing, which is basically a pip install directly off of GitHub right at the moment. Going back to here. So yeah, these are the libraries we're using for this project. Overall, I opted, so why Python, why CadQuery? So I opted for Python code to make the CAD model because I like making 3D models with code. Obviously, you have to have a passion for this and be willing to deal with it. I've used OpenSCAD in the past, but it has limitations for large projects, and a lot of it just has to do with like modularity, how the code can be split up, kind of the how it manages its stack. There's OpenSCAD has its uses, don't get me wrong, but for this particular project, I wanted to do it primarily with CadQuery. Pros of the project: Python has a large ecosystem. Parts of the model can be broken up into smaller modules and tested in isolation, and that needs to be actually written out correctly. Version control: I can review changes to the model before committing. That's actually a big one. When you're dealing with a project like this, right? The actual Dollhouse code itself is roughly just shy of 600 lines, but roughly 500 lines of actual code, 500 plus lines of code. To manage scope of change, having version control on this thing is, very helpful. It's actually a big deal. So be able to say, okay, before I commit this here, I got some breaking change. Be able to go over it line by line per commit, and being able to do that kind of stuff is a big deal. It's one of the main reasons for doing this with kind of source code effectively. And you have a kind of maintained history, but the history isn't as important as being able to see, okay, these are my changes, this is what I'm committing, and what I'm actually going to be outputting for the repository. GitHub code is kept in the cloud in a private or public repo. In this case, I started with a private repo. I've since changed it to a public repo so we can have a conversation about this code kind of in depth. Reusing the code from one project to the next is pretty straightforward. That has yet to be proven out, but there is a lot of code reuse in regards to the CQ Terrain project. Cons. So these are kind of the negative takeaways from this project. Tedious. The project itself was 500 plus lines of code just for the dollhouse itself. To be fair, it's a fairly large project, so take it or take it for what you will. The reusable API was expanded out as the model was being created, which slowed down development. So basically, as I needed reusable components, I was having to model that in CQ terrain and then, utilizing the API. So I was building out the API as I was doing this project. And that's kind of inevitable because I'm more or less scratch building a lot of this stuff, right? If there are bugs in your logic, tracking them down can be arduous. In particular, I had some bugs going on with the grid, how things were being laid out, and tracking that back and working that out can be a pain in the butt because it's all in thought space, right? The generated models do not lend themselves well to unit tests. And what that means is like for repeatable outputs, your primary output are your solids, and order of operations and how those get generated, you can run into some odd consistency things. And so I didn't, with this particular project, I didn't attempt to do unit testing with it. That may come down further down the line to try to figure out some more stuff. There's some steps you can take and some talk on the Google group about how to basically make repeatable outputs. All right. In the beginning, this is the initial outline of the project, kind of where the initial proof of concept. So here's the model, and so for the 9 sections, here you can see the actual layout of the 9 sections, the initial 9 sections. How this is laid out is effectively in CQ terrain, you have this concept of a building. A building has floors. I set this up to have 2 floors per building. This is set up as 3 buildings. I just put side by side. And then the roofs were appended on after the fact. And so with code, with the dollhouse, in this code itself, so let's look at a section. An actual section. So a kitchen. Okay. So here we have a building. We set up the length, which is the 7 inches, the width, 7 inches, the height. That should be roughly 14 inches. And then we set the number of stories. And so what that creates, and we can show that, is if I do an import CQ terrain, what I should be able to do is declare a building. And we'll get a blueprint off of that. And we'll do all that stuff, and I should be able to say bp.make, and I should be able to say building, and what do I want? From CQ terrain import, how's if I spell it right? Import in building, and so I should be able to say building make build equals bp dot build. Get rid of this other stuff. Nope. And we'll do this show part. And let's build that. What does that do? Helps if I spell it correctly. Import from CQ terrain. The Capitol building? It is Capitol building. I gotta do better with that. There we go. That is the rough constituent parts of the dollhouse. So you take 3 of these buildings, right? Join them up side by side. And here you can say things like, all editable. So let's say it's 3 stories. Now you have the 3-story setup, or 1 story. And so what this consists of is, we'll say 2. is so for each building, and really it's a stack, right? For each stack, you have n number of rooms. Each room has four walls, and each room also has a floor. If I show this with one, you can see that readily apparent. There we go. So here we have one room. It has a floor and it has four walls. In this case, it has a window automatically applied to each of the walls. And do I have this open again? Yeah. So this consists of three of these buildings slash stacks. Rules are applied to set up the windows per room, and then rules are applied to set up the doors. And then the roofs were added after the fact in order to fill this out. As you can see here, the front is very plain, and this highlights the breakdown of the 9 sections, and the back is still plain. On the next kind of phase of this, we added the exterior details, which built out the roof tiles, the Tudor front, and then the stone pattern. Compared to the original sketch, there's elements that got basically simplified out. So like this kind of awning on the front, the custom doorway, the chimney, all that stuff ended up kind of falling to the wayside for the sake of time. And then here, yeah, the interior is still plain, so you can't see that's interesting. Go back. You can't see the floor tiles yet. I don't have that in this particular model. And so we should be able to see, before I get too far here, entire model, wherever it is. I think that's the one, the test roof. That's the big one. Yeah. So this is the end overall model. And so the kind of the next part of this video is to go over individual details and kind of explain how they got implemented. The first detail to talk about are arches, and arches are very straightforward. Um, let's cut over to this. So hopefully we should have a camera of a actual printed part. And so effectively an arch, all it is we're going to create a cutout, a box, and at the top we're just going to, let's see exactly what I did. We're going to run a fillet and to round off the top. And then when we assign it to the wall, we're going to line it at the bottom of the floor. We have our room, we have our three walls. On our walls, in this case, we have two arches. Some rooms have three. We're basically going to be repeating this operation to apply the arch. So let's go back to the desktop. And so here you can see we're grabbing the bottom of the wall. So we're going to wall faces. We're grabbing the bottom of this guy. We're going to run this cutout operation, which is going to make a box effectively. So we're going to make this box that represents the arch itself, this guy, and then it's doing a translation on it. So moving it accordingly, and then we're going to round off the top of the arch by running this fillet operation, and then we'll have our wall cut out. So to show that, so here we have a building, and I'm gonna steal some code real quick. So we have a building. Let's do the build walls. So we'll say on our blueprint, walls we want to build. So on this room, we're going to say one wall is left out. We'll hit true. We'll run this guy. There we go. There's our cutout wall. Go back to 2 stories. And is that what I want to do for now? Yeah, that'll work. Do you have door walls? You do. Okay, we're going to steal this code. So we're going to say one of these walls has a door. True. Bam. Initial door. We're going to take out a window though. This is on the kitchen one. That'll work. I'm going to steal this code too. And basically, these are just the Boolean flags for saying whether to render a wall or whether to render a door or whether to render windows. Let's do that. There, that should be true to form. So this is representative of one of the corner buildings, corner buildings. And then here we're going to change out how we're rendering the doors with this. So with this custom code, we're going to make an arch door. And then I am going to steal my code. So we're basically assigning a custom method, which is this code right here. And we should be able to see that. So if I run this guy, there's our cutout arch, and our width and height is all sorts of confuzzled. Doesn't really matter. For the sake of this example, it probably doesn't. Width, length, height. Probably I'm setting them individually. Where is the door? There it is. There's my code. Let's fix that. Okay, so let's set that up. All right, so there's a lot to unpack with what I just did with that. Um, okay, where to start? Part of the premise here that you understand is a building is a class object with 2 life cycles. It has a make life cycle, which is responsible for building all of the subcomponents. So in this case, it's building out 2 rooms. The rooms have their own make life cycle and their own build life cycle. And then stuff like the floors specifically have a make and build life cycle, and maybe the walls do at this point too. I don't recall. Prior to calling the make life cycle, you can assign the attributes to the rooms. At this building level, we make a building that is basically generating off all the parameters with default values. Here we are overriding the values. So by the time we called make, this room property is set to these various values. And so when we call make, we're going to instance 2 rooms with these values of the wall properties, uh, the length, the height of the door. All of these parameters are being basically passed, and it's cascading down into the room. And that allows us to get some kind of a repetition of the process. So if I set this to, say, 3, well, we now have 3 rooms. And so all of that cascades down. You have an opportunity to step in here, and so once the rooms are instance, you can then start making specific declarations against the rooms. So if we go to bp dot floors sub1, that'll be the middle floor. So if we say floors 0, that'll be the first floor instance, and we can start changing parameters about that, right? Floor, first floor. And the problem with doing live demos like this is, do you remember what you implemented, right? Uh, things can go awry when you do this shenanigans on the fly. So we got our first floor, BP floors, and we can basically say, what is it? let's say window walls. So I should be able to say first floor dot window walls and then equals to something else. So in this case, we've got this guy. Let's just turn off all the windows. And so if I do this, I should be able to say first floor dot make. And what will that do? Probably break. No, it didn't. There you go. So even more to unpack. Um, this is how the customization was done on the house. So we have this concept of a building or a stack. We have a declaration of what its overall length is, what its width is, what its height is, how many stories it has. We're going to tell it to we're going to set custom parameters to the room. We're then going to run a make operation. And then if we need to customize a given room, prior to running build, which is doing all of the assembly, we can then start setting custom parameters per room, whether that's custom windows or custom doors or any number of these things. So there's a cascade effect. So at the highest level, when you set parameters at the building level, that cascades down to all of the sub rooms, sub walls, sub floors. When you set it at an individual room level, you're just affecting the walls and the floor of that given room. Okay, which is way off kilter, but we're talking about arches. So here we're making an arch, and let's set this back to 2, so I have some room to play with this. Boom. And so we're going to be doing stuff. On each wall that happens to have a parameter of 2, so true for where we're running door wall. So we said on this wall, we're going to create a door. And we can move that. So if we say true here, now we have 2 doors, right? On those given walls where we have doors, we're going to be calling this custom code of make an arch door, which is just a pass in, it's a callback method. We're going to pass in the wall that we're working upon, and then we have the length and the width and the height of the wall itself to work with, and then we have the height of the floor that we're dealing with. And those are being passed in because this is set at the level of the room itself. So it has access to all this attribute information. In this case, we're aligning the door, but we could just set it to the center of the wall too, which would be what? If I wanted to move that, and this is where things can get wacky. Let's try X. That did move it. Moved it up for now. You can assign it to various spaces, and I'm not going to get too in depth here because I'm going to end up breaking my demo. What if I did Y? Yeah, we can start doing some weird stuff. Front and back of Y. So that's at uh, the bottom Z. So if I did positive Z, that should be aligned to the top. If I said positive, probably is. It just went off the grid. Okay, because probably it tried to do the cutout. It's just it's up here somewhere, so I'd need to set it in the negatives. All right, so we'll set that back. So we have our alignment. So this is where we're going to align. Um, oh, this is the solid. Okay, so we grab the face, we grab the value of that, which gives us the bottom solid. So it's just going to return back that face. And if I just return back 0, I think it'll mess up my wall. But let's see, my wall should disappear. Yeah. So all bottom is that is the face of the lowest z index effectively. All right, then we have our cutout, and let's return back our cutout. We can see this. There we go. There's the doors. And so we create our cutout. We're going to grab the Z face of that. Oh, that's telling it. So on our cutout, let's just remove that. Cutout equals cutout. So right now our cutout is just a square box. When we apply this operation, we're going to grab the top and we're going to grab the top face, so the top Z axis face. We're going to grab the edges on that in order to round it. And then run this fillet operation, which is the length of what? Length of something. Oh, it's the length of the damn door, isn't it? Yeah, so this is the length and width of the door. Is what I'm passing in. So my parameters are slightly confuzzled. So yeah, this is the door and length width. So these are these values right here. So if I set this to 80, that should change. Yeah, okay. Let's set it to 150, and you can see what I'm talking about. Yep, there we go. Cool. So yeah, that's the length of the door. This one should be the height of the door then. So if I say 20, it should be silly. Oh, I didn't like that. Um, because of this cut command, it doesn't like that. Uh, let's say 50. Can I do 50? So 50 and 50. Now I have mouse doors. Okay. And so, it's not mandatory that you do this fillet operation. This is just for aesthetic purposes, right? So any type of whatever this callback calls, whatever you set to it is what you're going to get out of it. Okay, cool. And I can set that back. So 80 and 100. There we go. And so anyways, we do our cutout. And then the final operation is we take our given wall. We're going to do this wall.cut to remove the cutout. And then that's what we're returning back is the finished wall, which is this. Okay. And that's enough about arches. So we'll move on to the next feature, which is the stones. Oh, that's involved. This is a good segue for breaking this into a separate video. Where I'm going to continue with this is basically going into a deep dive into the creation of the various components of the house. So we'll going over the stones, making the casement windows, the Tudor framing, the lattice windows, and the roof in the next video. If you dig this, thank you. Thanks for watching this far if you made it. And we'll cover the specific details of the house in the next video.